Welcome back, guys. In this new video, we're going to handle a new topic that's important but a little bit annoying. The whole idea of polyatomic ions. Now, we're going to say that polyatomic ions are compounds that are made up of different elements, usually only nonmetals. There are exceptions to this, and we'll see them when we go through the list. So usually polyatomic ions are made up of only nonmetals, and they possess a charge. So that charge could be positive or it could be negative. Now, let's take a look at each one of these. So for the first category, we have singly charged positive ions. We're going to say that a positive ion is also known as a cation. And we're going to say, for the most part, there's only one that you're responsible in knowing, and that's NH4 plus 1, ammonium. So it's the only polyatomic ion that has a plus 1 charge. Now, the second one, the second cation that you're going to be responsible for, has a plus 2 charge. It's called mercury 1 ion. Now, you might wonder, why is it called mercury 1? Since it has a plus 2 charge, wouldn't it be called mercury 2? Well, what we need to realize is this plus 2 charge is coming from the combining of two mercuries together. We're going to say we have one plus 1 mercury combining with a second plus 1 mercury, and together their charge is plus 2. That's why we call it mercury 1, because it's a plus 2 charge coming from two mercuries. Now, those are the only positive polyatomic ions you're responsible for. Now we move into the negative ions. We're going to say that negative ions are called anions. And in the first chart, we're going to look at singly charged anions. So the first one, the most common one, is acetate. Now just realize that acetate can be drawn in two ways. It can be drawn as CH3CO2-1 or C2H3O2 negative. You're responsible for knowing both ways acetate can be written, because your teachers will go from one to the other any way they want. So just be aware of the both forms that acetate exists in. Now, the next one is going to be our cyanide ion, and then we have our hydroxide ion, and here's our first exception. We say that polyatomic ions are usually only nonmetals, but in permanganate we finally see that we have a metal involved. The Mn is manganese. Manganese is a transition metal. Now, this is an exception to the polyatomic ions because, again, it has a metal for the first time. Most polyatomics only have nonmetals, but there are a few that you're going to have to know that possess metals, this being one of the first. Now, you might next notice that I put nitrate and nitrite in bold. And what we should realize is, what's the difference between the two in name? We're going to say that this has an 8 at the end, but this has an ite at the end. How do we go from 8 to ite? What we have to realize is this has to do with the number of oxygens present in the compound. We're going to say that nitrate is NO3 minus 1. To go to ite, all you have to do is just remove an oxygen. So if nitrate is NO3 minus 1, nitrite is NO2 minus 1. So basically, if you know one, you know the other. If you know what nitrate looks like, then you know what nitrite looks like, because it all has to do with removing an oxygen. Now, for the next one, we're going to skip these and come back to them. Let's move up to our doubly charged anions. These guys have minus 2 charges. Now, you might also realize here that we have exceptions again. In both of these, we have Cr. Cr is chromium, and chromium is a metal, so that's another exception. Remember, for the most part, a majority of polyatomic ions only have nonmetals, but there are going to be some times when we're going to see metals involved. Now, you might notice next that we have sulfate and sulfite. Same exact pattern we had to remember from the last time. How do we go from 8 to ite? Remove an oxygen. So if sulfate is SO4 2 minus, then sulfite, just remove an oxygen, it's SO3 2 minus. The charge stays the same. It's just the number of oxygens that are changing. Next, we're going to move to our triply charged anions. Again, they're both in bold. We have 8, we have ite. So if phosphate is PO4 3 minus, Remove an oxygen, that gives us phosphite. Charge does not change. Only thing that's changing is the number of oxygens. Now, let's go back to here. We have our doubly and our singly charged anions. And we're going to say that this right here is called hydrogen phosphate. From the name, we can know what the compound looks like. We're going to say if you have a polyatomic ion and hydrogen is in the name, we're going to say hydrogen exists in group 1A. Group 1A ions are +1. So this is +1. So we have a hydrogen +1 combining with a phosphate. We just saw that phosphate is PO4 3-. So all you have to realize here is that we have this +1 combining with this -3. So if you work that out with basic math, that gives us a -2. So that's why our compound is HPO4 2-. It's the positive one that's reacting with the -3 in the phosphate that gives us this -2 charge. Now for the next one we have dihydrogen phosphate, so that means you have two H pluses still reacting with phosphate. Now we have two hydrogens, each one is +1, so overall that's +2. So we have a +2 and a -3 reacting, and because there's two hydrogens we put a 2 there to signify that there's two of them, and then we have PO4 -1. Hydrogen carbonate can also be called bicarbonate. So remember both names. And how did we create this? We just had an H plus combined with carbonate, which is CO3 2-. That +1 from the hydrogen will combine with the -2 from the carbonate. -2 + 1 gives us a -1 charge. And then finally the last one, hydrogen sulfate or bisulfate. So again, that's just H plus with sulfate, which is SO4 2-. Again, the +1 and the -2 combine to give us a -1 charge overall at the end. Now, these four compounds might seem a little weird, but just remember, as long as you can remember what the sulfate, carbonate, and phosphate look like, you should be able to name them and draw them correctly. So basically, you have to remember the ones above to be able to do those last four that we covered. I know the polyatomic list might look really challenging. It's a lot of information, I get that. But just remember, separate things into different categories. Who are our cations? Who are our anions? From there, break it down into the charges. Okay, which cations are +1? Which ones are +2? For my anions, who's -1, -2, -3? And then remember the trick that we learned about nitrate and nitrite, about sulfate and sulfite, about phosphate and phosphite. Knowing that already eliminates 6 of the polyatomic ions you're responsible for. Then the rest you just have to sit down, look at it, see the patterns in order to remember the names. A lot of things connect together. So the more and more you look at it, the easier it'll be for you to understand and memorize the information given to you. So good luck with learning all the patterns that we talked about.